think I can fix this. Alright, got my pen.
That's,
My pen,
that's his pin.
my pen, my pen.
Yeah. He's trying to write with a valve. There you go. All right, what we got here,
Piece of lead.
we got this, thing. The reason I call this change without notice, you'll run into that. We've got, sometimes whenever you're working on stuff, coincidences happen. And a lot of the times, what you gotta do is you gotta take a good close look and see if whenever they come back talking about it wasn't like that before, you gotta give them the benefit of doubt. You gotta determine if you did do something. Because sometimes you can determine that you did do something, and sometimes you'll determine that you didn't do something. This 84 Marquis belonged to a relative of mine, and it went for a transmission service. When I was at the dealership, the transmission mechanic, I was a transmission mechanic too, but he wound up getting the job. And so he did a transmission service, and he was really a good mechanic. He'd been doing it for 20-some years and all that kind of stuff at the time. So what happened was, he gets through, sews it up, she pays the bill, she gets down to the red light, all the transmission fluid goes out all over the highway down there. That sounds like he did something wrong, doesn't it?
I don't think he ever did it like I did.
No, well, that's doable, but he didn't overfill it because he knew better than that. But he'd serviced bunches of these. So anyway, bring it back up there, and when we get it back up on the lift, it turns out there's a little roll crimp around where the transmission line goes in. The transmission had split, and it had leaked all the fluid out because of the line. He was nowhere near that line. He didn't touch that line, and it just happened to split about the time. It was like my sister told my dad to put brakes on her 77 Caprice, and after he put brakes on it, the radio was blowing the fuse. And he had nothing to do with that, but they were blaming it on him because it was working when he pulled it into the shop. That's how that kind of thing worked. Anyway, that was the mark. When it's not a coincidence is whenever we actually did do something wrong. The Blazer, and I mentioned this one before, but I'm going to talk about it again. This S10 Blazer was came in here, and we had to fix an oil leak. So we pull the transmission out, we put the transmission back in, we got all that going. He comes back a few days later, and he says, I haven't been able to use the key to get in my hatch in a long time, so I use the push button release inside, and after you guys put the transmission in there, the push button release doesn't work. Does it sound like it's related? Sound like it's got something to do with what we did? This is the way it's wired up. After I looked at the wiring, I figured out we did it. Because what happened was, they don't want the in-gate lock to work. I mean, basically, they don't want your in-gate to open, your actuator, that's the window actuator, and then, let me see, I've lost it here. One way or that's the front side door lock, but whatever happens here, you see this right here? I don't want to go too deep into that, but this right here, the park neutral backup lamp switch is on the side of the transmission, and the guy plugged it back in, but not good enough to provide a ground for the actuator to open the back. See what I'm saying? And they're calling that in-gate window release actuator, but one way or another. This thing wasn't plugged in good when he put the transmission back in, and that's why this wouldn't work. Because they don't want you open it to accidentally open it when you're going down the road, because you'll lose kids, dogs, ice chest, all kinds of stuff if you're driving down the highway and you open your in-gate when you didn't mean to. So if it's in drive, it won't work. Remember that.
You wouldn't lose kids if they were in a seatbelt.
Huh?
Just saying.
Yeah. Well, I mean, you're not going to seatbelt your dog or your ice chest or your grandfather clock if you don't want to. So we like these smooth and straightforward repair jobs, the ones that we like. They're the routine work orders where there's no surprises on either side. Little simple condition, cause, correction, flow. You know, this is the condition. We got a misfire. We got a call on a spark plug. We put it in there. Poof, everything's fine. And this Mitsubishi Raider was at a shop that was over at Enterprise, and it had an engine skip under load. The owner said the other shop had replaced the Raider's ignition switch at a cost of $400, but his engine skip remained the same. Does that sound peculiar to you? If somebody would put an ignition, I don't know what they were thinking, if they found a technical service bulletin, if their diagnosis led them in that direction, I don't know what it was. Don't know why the job went in that direction. I can't speak for the other shop, and I'm not trying to, trash them or anything like that. But basically, cheap and easy is the best first move. So we jerked the spark plugs out. We found the original spark plugs still in their holes. That's what they looked like when we got them out of there. All it took to fix the truck was 30 minutes and a set of spark plugs, and they weren't hard to change. Engine skip was gone. He was happy as a lark. I'm still wondering about the ignition switch replacement. I'm not sure why that was necessary. Here's the Santa Fe. Now we're getting into an air conditioner thing, which today's air conditioner day. This one had an inoperative air conditioner due to a dead evaporator sensor. Now, it had been to the dealership somewhere, and they had spent $3,000 or $4,000 getting a compressor and all of the other stuff put on there. And whenever the smoke cleared, it still wouldn't work. And they were just so disgusted they were going to trade the vehicle in, but they brought it here as a last resort. And we basically did the little dance on the control head, and we saw a code that said the evaporator thermistor was reporting a freezing evaporator all the time. You know, it basically threw us a code saying it was open. So what we did was we went ahead and pulled the dash out, which you can see how much of a job that was. It was a big job. Lee pulled it out, and he put an evaporator thermistor in there. I've still got the old one laid over there somewhere. And when he got it back together, it was working. And that customer was so happy that that air conditioner was working. He says, "Can I give this guy a tip?" And I said, "That doesn't have anything to do with me. If you give him a tip, it's between you and him." And so Lee came to me after it was over with, and he says, "This guy gave me $160, you know." But anyway, I took every $20 bill out he had in his pocket and gave it to him because he was so happy that air conditioner was fixed. And it still works too. Long and the short of it is, sometimes you have these landmines. We have a T-Rex and we have a landmine. You know what I'm saying? The T-Rex wants to bite you in the butt. The landmine is whenever you're just going along here and you step on something that blows up in your face. And I was working at a Volkswagen dealership one time, and we did valve adjustments all the time on those Volkswagens. And they had little chem followers that went down in these polished holes in the head and the chem. You know, we'd push those down, put different shims under there, and we'd have go, no-go gauges so we'd make sure they were getting them all right. And we'd turn them through, and $18 is what we charge for a valve adjustment. Well, this guy came in there one day needing his valves adjusted on that Volkswagen, and it was a diesel. And I noticed the valves were all really, really loose. And so I put the shims in there to get the valves like they were supposed to be. And you know, the engine was still warm, cranked it up, drove it outside, parked it. When he came to pick it up, it turned out that since those chem followers were going deeper into the holes, they were sticking on the varnish that was down in the holes. And whenever you'd spin it over, it would go click, 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 because the valves would stick open and the piston would tap the valve and it would shut. Now, it didn't do anything like that when it was warm, which is how come I missed it. But when he came to pick it up cold, he screamed and hollered and threw a fit and said he wasn't paying nothing and he wanted the car fixed. So all I did was put his original shims back in there, loosen the valves back up, wash the engine off really good, and send him on his way. Because I was not going to do a bunch of free work pulling the camshaft out, pulling the cam followers out, and cleaning those holes out. Because he wasn't going to pay me to do that. And I wasn't going to pay anybody to do it. Anyway, he wound up, driving out there with loose valves. But anyway, that was a landmine because all I did was the same kind of thing I always did, 10 times a day. And in that particular case, it blew up my face. And sometimes that kind of thing happens, Simple repair. Okay, so on this one here, how it all started, this 98 Buick, the AC was inoperative, the low coolant message was on, and it was burning out stop lamp bulb. Now this girl bought this vehicle to use for just a year. She was over here from Germany as a foreign exchange student, and she paid, like $2,500 for that car, and she liked the car, so she brings it in, and we're checking all this kind of stuff. And so this seemed like a simple enough thing. So we pulled the air out because it had gone completely atmospheric. Anytime the air conditioner system has gone atmospheric, and you can tell by whenever you hook your identifier up that you're seeing nothing but air, pull the air out of it, put juice back in with a little bit of dye, and you basically, the air system was going to be leaky, and it was late on an Thursday afternoon. We weren't going to be able to work on it, very long. So we went ahead and pulled it out, put that in there, and we sent her on. We're going to do a follow-up. So she left out of there, with an air conditioner that was cooling, and she would come back the following Monday. So she shows up the following Monday. The low coolant message had been joined by a trunk of jar message, and the AC's refrigerant charge had mostly gone away. This we expected. This right here was strange, and we really didn't know what to make of that, but that was just, neither here nor there. So we used our black light, hit the bottom of the AC compressor, looked like it was radioactive because it was just dye. And an AC compressor is a very, very common leak point. You're going to see the AC compressor leaking a lot of the time. So we charged it up with dry nitrogen, and that's what you're seeing right there. And we sprayed the soap on it, and we had bubbles all over the compressor. So we had to put a compressor on it. We recovered a little dab of refrigerant that was still in there. And we did that nitrogen thing. Hello. And this was what the compressor looked like. See all that dye coming off of it and everything? Very common. So we went ahead and put a compressor on it because it was time to do that because the compressor was leaking and you can't really take those apart and rebuild them. Pulled it out, charged it up, ready to feel the nice cold wind, but the compressor wouldn't even engage. So we got no compressor engagement here. And while we're investigating that, one of my guys noticed the temperature needle was dangerously near the red line and the cooling fans weren't working. They were working the other day, last Thursday, but now on Monday they weren't working. This is what I call change without notice. Did we have anything to do with this? No, we did not. but it's a problem. And what happens here, let me go on and tell the story of it, I'll put it up. The loss of compressor operation, the dead coolant fans, and the trunk of jar message had all come out about over the weekend at the same time. Is it possible they could be caused by the same thing? All right? So none of these symptoms has existed during our previous service. It was a circumstantial landmine. Boom! Blew up in our face, right? Okay, developments always feel like a smack in the face. The customer is expected to get that car back nice, cold, and fixed and all that kind of thing without a hitch. But inoperative cooling fans will destroy the engine. We let it out of here like that. She sits a while at the drive-through. Next thing you know, she's pegged out. She's, took the temper out of her ring. She's blowing gaskets and all this kind of thing. This one simple problem has been replaced by two bigger problems that require stronger troubleshooting techniques. So the compressor not engaging was a problem because she was paying for a compressor that now wouldn't work, So I put a couple of guys to work on the trunk of jar message. And so we started to gather data on the AC no engagement, unresponsive cooling fans. But all these guys found was normally operating trunk of jar switch with good voltages and circuits and all that. So we closed the trunk and figured, well, we'll put that on the back burner. Okay. You don't release the vehicle once again if you got coolant fan issues. The failure of the coolant fans was a big problem, and the coolant fans weren't faulty. Here's how they're wired. You guys have seen this before, right? I showed you this the other day. Basically, when you energize this relay, it goes through that relay, and it goes down here. So it's the voltage is coming through here. It's going through both relays to ground, so they're running at half speed when you energize this just one relay. Now, when you energize these two relays, it kicks them both on high because now you're basically shooting juice straight to this fan, and you're basically flipping that one over so that your ground is coming to this one. So what we did was we found out where the relays were. You know what I mean? The coolant fan relays. And what we look at, when we basically look at these, we can figure out that that relay, that one, and that one are the players that we got in this thing. Okay, so here we got the junction box. 34 is coolant fan run relay. That's the one we're going to pull out to do this test that I'm talking about here. Then you got these other relays. I'll just leave those alone, pull this one out, and you're going to hook up and see that's what it looks like in the actual cluster. So what we did was we pull this relay out, and we make doggone sure we're on the right terminals. We're going to go from the one that's hot all the time to the one that feeds the coolant fan, and we're going to use a light that's pretty, low impedance. In other words, we want a light to pull some current. And this light's going to burn, and as we turn these fans through, one at a time, like you were doing the other day. Who was that? You were doing that. You turn these fans through. If that light ever goes out, the fan you were turning when that light goes out needs to be replaced. Even though you may hear it kick on and off several times, and if it ever stops in that dark spot, it will not run. So basically, you're checking both fans from that one place, and that's the slickest way to do that. And I basically drew it like that. We can look a little closer at it here. Let's see if we can zoom in on that a little bit. See what we got there? We basically have taken our relay out. We got it laid to the side over here. This is where the relay used to be. This is what goes to the coil. We're not concerned with that right now. We can check that later if we need to, but right now we're trying to make sure the fans are okay. And the fans were okay. So we need to go a little deeper here. With a two-way talk and scan tool, we told the PCM to turn the fans on, and it turned them on both speeds. With the car running, though, it wouldn't turn them on. With the ECT sensor disconnected, the PCM would activate the fans, but at low speed. So if you disconnected the ECT, it would turn the fans on by default. So what we now know, everything was in place, driver circuits, good relays, good fans, and all that. If it can turn them on, we've already checked the fans. We know the PCM can turn them on if we tell it to, or if we disconnect the engine coolant sensor. Okay, so we're going to fool the PCM. Here's your engine coolant sensor right here. Right? You might notice that the powertrain control module is on the bottom and the top of this schematic. That's the same box. It's just that both of these wires go to that. And then there's another one over here that feeds the signals. There's two thermistors built in there. One of them goes to the instrument cluster. We ain't worried about that one. So we pulled the coolant sensor out of the way, and we took a potentiometer. You buy these at Radio Shack or wherever, and you're just going to hook two legs of it up where the engine coolant temperature was, and with your scan tool, you can basically monitor that voltage while it's going to be a 50,000 ohm potentiometer, and you turn it until you get the coolant temperature you're wanting. So you're fooling the PCM into thinking the coolant is really, really hot. You're not heating the engine up, which is a good thing. engine running on these GM cars. To do this job, the engine's got to be running. So you dial it up to where it says 267 degrees or whatever. If the fans don't kick on, it means something is causing the PCM not to turn the fans on, but we don't know what it is. I'm telling you, this was a wild ride. Okay, so here we are still struggling with this. So this is what we're talking about here. We dialed it up, and I see an engine destroying temperatures on the PID, but the PCM was refusing to turn on the fans. It's telling me I don't care what the coolant temperature is, I'm not turning the fans on. This didn't make any sense. All right, and this is not the first time I've seen this kind of nonsense. Well, now we're looking for the AC on the scan tool. Showed the control head was sending a request, and the BCM was receiving the request, but that's where the request stopped. Okay, the AC requested, yes. BCM wouldn't message the PCM to turn on the AC, and that's what the BCM was telling us via the data stream, and the PCM's data stream verified the lack of a request. Okay, now you might see right here, this right here was the PCM talking. It says no, commanded AC off. It was supposed to turn on the AC, but it just flat wouldn't do it. And this is the little relay that turns on the AC compressor clutch. Does anybody know what that diode right there is for? Anybody got a clue as to what that diode's in that circuit for? You notice that diode is basically wired with this little arrow pointing up. And so basically, whenever you go through here, you know, current can't go anywhere except back this way. So it's not going to short out unless this diode's bad. Whenever you de-energize an AC compressor clutch, it acts like an ignition coil almost, in that all of that magnetic field sweeps across those windings and it creates about a 400 volt spike. If this diode is not in place, a 400 volt spike will go screaming back into the PCM if it's got a circuit where it's monitoring that. And so basically that's a bad idea not to have that clutch diode in there. Those have been in there ever since ACs have been on cars almost. Alright, so anyway, that was just a little sideline there. Well, this isn't a voltage deal you can measure or interpret. Class 2 message transfer for between these modules. We're obviously dealing with a software issue of some kind. We disconnected the battery terminal, touched them together to see if we could clear everything out. And I even went so far as to reflash the PCM just to see. You know, I say, well, let's just try this and see what happens. You know, you can hope. You know, didn't touch it. All right, so here we go. Went to Identifix. Then there were posts on that problem, reflected issues with the VCM, PCM, wiring, and so on and so forth. There wasn't any silver bullet though, so I checked with the GM dealer and found out a replacement body control module costs about $400, and that was a non-starter as far as I was concerned. So I called the salvage yard over there, Fulferton Enterprise, said they had one on hand for $45. So I went by on the way home and picked it up, put it on the next day. That was, I think by this time it was like a Friday, and I was here by myself. Nothing had changed, or maybe a Thursday, either on that LCD scan tool screen or on the vehicle itself. Everything stayed the same. And that's when I realized there was a problem here. That they had given me the wrong box. The BCM and the HVAC programmer, which is what they call this, the other thing. This right here is the BCM. But the HVAC programmer is right next to the BCM. They're just mounted next to each other. And so when they went under there to get the one out of the Buick they had, they just pulled me a box out and threw it at me, and it wasn't the right one. And say they're mounted right next to each other behind the glove box. They look like, now typically, I will tell you this, you do have on some vehicles a little AC amplifier. Asian vehicles, you know, kind of like to put all of their electronics with the AC going through a little electronic box they call an amplifier. GM calls the box that controls their automatic temperature control an HVAC programmer. You understand what I'm saying? Okay, so the 71 Cadillac that the president's got has got a great big old device over here on the right side that interfaces with the automatic temperature control, and this thing is huge. I mean, it is a big thing. It's up under the dash on the right side that's got all sorts of analog stuff and vacuum diaphragms on it and all that, and servos. And that big unit is called an HVAC programmer. Even, you know, which is basically, but the HVAC programmer looks like this, only it's got a different color connector. There is a reason why they make the connectors pink. They're mounted right next to each other behind the glove box. Alright, so when I plugged that one into the Buick, everything came online, the AC worked, the cooling fan started to operate normally, the trunk and jar warning went away to be replaced by change oil soon. The entire problem with that car was what?
BCM.
The BCM, for some strange reason, was preventing the PCM from turning on the fans. And so how are we supposed to know this is possible? Because you could go to the scan tool and you could talk to the BCM, and you could talk to the control head, and you could talk to the doggone PCM. Everybody's talking, so it's not like we got a module that's offline. But you know, whenever we got up here, it kicked the fan on like it was supposed to and all that kind of thing. That was pretty doggone spooky. This is the thing, you gotta be really careful when you're working on something. Like for example, if you've got a vehicle that overheated, like I said the other day, and you don't find out why it overheated before you do the heavy duty repairs that were caused by the overheating, you may see it again. And it's not gonna be a pleasant experience, you know. Because if it overheats again, even though you did everything right, if you didn't find the root of the problem, you better find out what was causing it, you know, before you actually go in there and say, we've taken care of this and it's fixed, okay? Let's see if it'll go.
It's hard to do that though, if you don't replace the stuff, yeah.
Well, you gotta go and do your repairs. That's beyond dispute. But after you've done your repairs, don't be so lazy that you say, whoop, I got this head gasket changed out, everything's gonna be fine. We did the, you know, the things over here, we sent it to the machine shop, they did a valve job, they machined the head, it was warped, we put a head gasket on there, we're sending it out the door, and then you find out the stupid cooling fan wasn't working and it does it again. You see what I'm saying? And that's, you gotta find out what the original root cause was. You know, and sometimes people will, like the other time I was talking about that Eagle Talon that came in here with a dead engine controller. It was putting out no reference voltage on the line going to the cam and crank sensors or whatever. And so we found that, we put an engine controller on it, it ran 20 minutes and burned up that engine controller. The same way. See what I mean? One time my buddy Donnie was working on a Jeep Cherokee, and it was actually a Grand Cherokee, and it had fried the engine controller, and he troubleshot it and went all the way down to the line, and he put another engine controller on it under warranty, it was $800, and he cranked it up and it ran for a few minutes, and about the time it got warm, it fried that engine controller the same way. He went through his book, he went through his modules, he went through everything, and he checked it all out, and he couldn't find anything else wrong, and he was, you know, tightened a few grounds and all this and made sure the pins were tight everywhere. And then he put another engine controller on it because that's what the hotline told him to do, and he cranked it up, and about the time it got warm, it burned that engine controller up too. And bless his heart, he was sitting in there at the service manager's desk on hold waiting for the hotline again, and he looked just plumb downtrodden. And I says, Donnie, are you okay? He says, that Jeep has burned up another engine controller and I'm disheartened. He'd been working his fanny off on this thing. Well, you know what he found? It was something that wasn't even in the book. That particular Jeep had a hydraulic cooling fan. You ever seen one of those? The power steering pump had lines going through some solenoids over here to the cooling fan, so that whenever the engine controller wanted to turn on the cooling fans, it would route hydraulic oil pressure from the power steering pump through the cooling fan, and that's what ran the cooling fan. It ran hydraulically, not electrically. But there was an there was a ground for the electrical stuff that, you know, enabled the PCM to control it, and that ground was dancing around loose. And so basically, you remember the little diode I told you about? Mm-hmm. You know, basically when it was dancing around loose, it was sending spikes in there to the PCM. The PCM can't handle that. I mean, it can't handle a whole bunch of high voltage spikes punching it in the teeth. Because what happens is it kills that circuit, and this little chip goes down, and no smoke comes out of the PCM, but all of a sudden it's not talking anymore. Here's another thing. If somebody's welding, doing body work, and they say, well, we unhooked the battery, that should have protected the PCM. Well, that is not going to do it. The only way you're going to protect the modules when you're welding is unhook the module. Not unhook the battery, okay? Secondly, another smart thing to do is if you're welding on the frame back here at the back, don't put the ground clamp up here at the front. Because if you're welding, try to put the ground clamp right next to what you're welding on, and you probably won't have any trouble. But if you put it somewhere else where it's got to go through the engine controller to find the your welder, you see where I'm going with that? I mean, we've seen that in the body, we had auto body here, they had a Dodge truck that happened to. They said, well, we unhooked the battery, and so it wouldn't talk, and so I got an engine controller that had the same plug on it that I got off a Jeep Grand Cherokee that was a bad one for some other reason, and I plugged it in and it talked just fine, so I knew the engine controller was dead. You know what I mean? All right, so the description and operation section is usually a good place to go, but in this particular case, it did not explain the complicated relationship between the various modules, and sometimes the best and most reliable information comes from tough experiences, clear reasoning, and retracing our steps when we find ourselves at a dead end. So, the description and operation section was totally silent about the BCM's role in cooling fan operation. So we had control head talking to the programmer, talking to the BCM, talking to the PCM, which operated the compressor and the fans, and for some strange reason, this bonehead would not let him turn the fans on. And the PCM wasn't intelligent enough, to explain this. I'm unplugging the engine coolant sensor, and the PCM says, whoops, I don't know what the engine coolant is, I better turn on the fans. But the thing about it is, as long as the engine coolant sensor was given reliable information, this guy right here could tell this guy right here, don't you operate those fans until I tell you to. And the PCM says, okay, I guess that's what I'm going to have to do if I have to. So that's what we're going, that's what I'm saying. This is the kind of crap you got going on talking, and that's just a 98 model. Imagine what you got going on in 2014 and 15 and 16. This is the kind of stuff we have to deal with. After the oil change was done and the bill was paid, the Buick driver got her wheels back with everything working really smooth, but 2 weeks later she was back with harsh transmission shifts and a stalling concern.
Sounded like she needed a new car.
No, she was not going to buy a new car because she bought that one to drive for a year, and then she had to sell it when she went back to Germany.
She got a limit.
All right, the transmission had a harsh 2, 3, and 3/4 shifts. It would stall sometimes during parking lot maneuvers. The mill was on with a math code we hadn't seen previously. The data stream showed mass airflow readings about 1,000 hertz lower than was accurate. After we put a mass airflow sensor on it with one from the parts store, the transmission cleaned up its act and everything was wonderful. And she drove the car for another year and never had another problem with it after that. Now, occasionally, you'll get to the point when you're working on one to where you feel like you just want to set fire to it. You know what I mean? That does not mean it's okay to set fire to it. Although when I was working at the Ford place, I would accidentally set fire to about one a year. But you better have a fire extinguisher close by, to put it out, because occasionally, things happen. I was in the parking lot one day out there, troubleshooting a Taurus way away from the service, and I'm saying it was a no start. And so what I did was I checked the spark first, and then I checked the fuel pressure, and there was a little bit of fuel that ran down there. And then some spark came out of the distributor somehow and set that fuel on fire. And it's a little flame burning around the distributor. Well, you know what happens if you leave and go in the shop trying to find a fire extinguisher? It burns the car down to the wheels. So I blew it out, and it came back. I blew it out. It came back. I blew myself out of wind. Help! Help! Somebody help! Help! It was like that fire just wouldn't go away. Finally made it go out and stay out. I didn't know what I was going to do about that. But anyway, that's the end of the slideshow. Now, let me ask you this. Did everybody have a good time? Yeah. This is what I'm trying to tell you. This stuff right here is a grand adventure. You see all them AC parts we got laying up there? Every doggone one of them usually came off of a car that we had to fix an air conditioner on. And it's basically, a lot of the times you got electronics on there that you have to replace. Now you can look at a salvage yard typically and find a part that you can get for your AC that doesn't cost quite as much. The body computer, you didn't have to pay $400 for a body computer. If you can get one from the salvage yard, go for it. That's what I'm going to say. All right. So what we got to look at on Quincy's car is find out why his $400 throttle body is going to have to be replaced, and then we'll have to get him a $400 throttle body. Ain't that right, Quincy? All right. Quincy's excited about that, isn't he? All right. And so we got to get the right radiator for that one there, and we got and Dustin's got enough work to do on that expedition to keep him done very busy the rest of the week. And when will you have your transmission out?
When Zach gets here.
No, you got to work on it when Zach is not here, because we're not going to put it on the back burner just because your helper's not here for a couple of days. We got to get that done. All right. So what did you do at work on Friday?
You just went over one of them.
Is that right?
Yeah.
Oh.
Oh man, I didn't want to say nothing, but we just went over one with the Jeep. They had the same problem, and I told them exactly what I thought it was.
What was the problem you were having with the Jeep?
Well, the fans weren't cutting on at all. And I told them, grab a test light and do exactly what you're talking about, to see if there's any broken spots. If there was. And then so they changed that out when they finally listened to me. Then after that, I knew something else was wrong.